Okay, so the last thing we're going to talk about here are z-scores. I'm not going to go through it, but if you've heard of percentiles, percentiles are like quartiles. This is from the last lesson. But a quartile divides the data up into 4 chunks. A percentile divides it up into 100 chunks. So if you're in the first percentile, you're either one of the smartest people around or vice versa. Because it's not totally clear whether... Sometimes they'll say like the top percentile or the bottom percentile, something like that. But what we're talking about here instead is we're talking about z-scores. So z-score has a definition, and the definition of z-score is number of standard deviations away from the mean. So for example, let's say we had some data and the mean was 29 and the standard deviation was 3, and I want to know what is the z-score of a data point of 35. So we have our mean, which is 29, and if we went up a standard deviation we would be, right, so if we go up a standard deviation we would be at 32, and if we went up another standard deviation we'd be at 35. I didn't space those right at all. So we went up another standard deviation. So we see that a 35 is 2 standard deviations above the mean. So the z-score here, so therefore the z-score is 2. So it's 2 standard deviations above the mean, so the z-score is 2. Now, let's say the mean, let's have the same one, so the mean is 29 and our x value and our standard deviation is 3, but our x value is 20. So here, the mean is 29, but now we're below. So we're going to go, if we go, as we go down our standard deviations, right, we're going to be minus a standard deviation and minus a standard deviation and then minus a standard deviation. So what we could see is that 20 is 3 standard deviations below the mean. And the way we show that is we show that z is -3. Now, let's say for example the mean was 29 and the standard deviation was 4, just to make things pretty, and our value is 30, and I want to know what the standard deviation is there. So we know in this case the mean is 29 and 1 standard deviation above would get us to 33, but we want to know what is the z-score of 30, and that's going to be a quarter of the way over there. So this is the whole standard deviation, but it's going to be a quarter, so we would say that z would actually be equal to positive 0.25. It's a quarter of a standard deviation above the mean. And there is a formula for this that you possibly could have figured out yourself just by looking at these examples. But the formula is going to be you take the deviation and divide it by standard deviation. And that's the formula for z-score. And as we're going to find in the next unit, z-score is one of the most powerful tools in statistics almost. It's a very good way. In fact, when I was young in Quebec, they would report our scores off on a z-score. So for example, if you had, I'll show you. So let's say for example, a physics class had a mean of 73% and a standard deviation of 5, and a dance class had a mean of 91 with a standard deviation of 3. So let's say your mark in this class was an 80, an 88, no, we'll say an 83, and your mark in this class was an 88. So which mark is better? And so the way they used to report it when I was young, and this is in Quebec, and I don't know if they still do this, But this one would actually be reported as a z-score of +2. So you've done better than the average, and this would be reported as a -1. So your physics mark would be a +2, and your dance mark would be a -1. We don't do that. We do put class medians on the report cards, which may or may not have an effect. But either way, that's z-scores. And so your job for today is to go through these lessons, make some notes, and I'll give you some work on it the next day.